Good day. And why is it a good day? It's a good day because we're doing mathematical literacy once again. And folks, today I'm really excited because we're doing a topic which I just absolutely love, and that's a topic on Mapwork. And why do I love this topic so much? It's because we can use it nearly every single day of our lives. So let's get started. Right, the first thing we're going to do is, in this session, I am going to talk about direction on maps. We're going to look a little bit about grids and grid references on maps. And as well, we're going to be looking at some map scales. First of all, let's have a little bit of an introduction. And in this introduction, I'm going to try and explain to you where Mapwork fits into our whole syllabus. So let's have a look at this quickly. First of all, we need to understand that there are 4 different components in your maths literacy. There's learning outcome number 1, so we have LO1, and that deals with numbers. And by numbers, we mean things like finances, like rounding off, finding different ratios, okay? Everything to do, even with your calculator work. So we deal with numbers. That's learning outcome number 1. And folks, that counts 25% in your final examination. So that is 25%. The next is LO2. And in LO2, we look at things to do with graphs. So we look at straight lines, we look at where one line will cross another line, we look at all different real life situations with which we can draw a graph. Okay? Again, that'll count 25% of your final year mark. Then we get LO3, and this is where we now begin to slot in. But before we look at that, let me jump and say, in LO4, in other words, learning outcome 4, we look at things such as statistics and then, of course, probability. And again, that whole section will count 25%. Now, LO3. LO3 is broken up into 2 parts. The first part, we have shape and measurement, where we look at volumes, we look at areas, we look at perimeters. A lovely section. Okay, so we have all these different shapes. And then we also have map work. Now, combined, the shape and measurement and the map work combined gives us a further 25%. Now, I want to stress that in learning outcome number 3, your shape and measurement probably takes most of the marks. Your maps might count only about 10%. So why are we going to spend this whole session looking at map work? Because every percent counts in your final exam. Okay? And if you're in grade 11, or even if you're in grade 12, your teacher may decide to give you a test just on maps. And then that map test counts a full 100%. So you've got to understand every section in your curriculum, okay? So learning outcome number 1, numbers, 25%. Learning outcome number 2, graphs, 25%. Learning number 3, shape and measurement, as well as maps, 25%. And learning outcome number 4, statistics and probability, a further 25%. Right, let's jump back now. So we've spoken about where it all fits in. Now let's have a look at direction. Now before we get to direction, I want to say this, that what is, or let's answer this question, what is this whole Mapwork section all about? Why do we have to do it? Well, before we look at maps, I want us to look at this little tiny picture. And you're not even going to be able to see it because it's so small. But it's a picture of me. And this little picture is also a picture of me. So we have one little picture, and a real life picture. So over here, in this picture, I was a good-looking little fella. In this picture, I was a good-looking little fella and fat. In this picture, I'm just fat. But the difference is the size. It's the same character. This here is a guy called Pete. This here is a guy called Pete. This here is a guy called Pete. Okay? So if my wife were to want a picture of me and carry it in her wallet, okay, and I hope she would want a picture of me, and I hope she does keep it in her purse, because if she doesn't, no one else will. But she's going to take one of these little pictures, okay, one that's been reduced in size. She's not going to get a picture in this size. First of all, she's going to need a very, very tall purse. And second of all, she'll probably need a very wide purse. But now we're getting personal, so let's go away from that, okay? But what we're trying to say is that's the picture she's going to want. One of these two. Probably this little one when we were just sexy, not when we were fat and sexy. So this is the picture she's going to want. She's going to put that in her purse. Now, folk, in the same way, maps is also a smaller image of the real thing. Now, I'm sure you've looked at your teacher and they've tried to teach certain things. And some teachers use an overhead projector. Some schools might even have a data projector, which is connected to a computer. And it shows up on a big screen behind the teacher, or shows on a big screen against the wall. And what you're seeing on the screen is not the same size as what the teacher has on her little computer. Or, if she's using an overhead projector, what you're seeing on the screen is not the same size as what she's got on the projector. It's the same thing, but a different size. And that's the basic concept of maps, okay? Same image, but just a different size. This here, same image, just a different size. This is a whack smaller than this thing standing here. We understand that? Great. Another concept we have to come to grips with is this whole thing of direction, because maps are all about direction. Am I going north? Am I going south? Where am I actually going? So let's have a look now at our screen over here. And on our screen, I've actually got a representation showing different directions. So we can see here that were this to be my focal point right over here, if I were to walk up the screen, I would be going in a northerly direction. Were I to be going down the screen, I'd be going in a southerly direction. So we have north, we have south, and those are our two main points. If we don't understand where north or south is, we're not going to understand where any of the other directions are. Okay? Our next two important things are these two guys over here, west and east. Now, we normally have a lot of students who confuse west and east with east and west. Okay? So how do we remember? It's quite simple. If I put the W first, followed by the E, I spell the word we. Okay? If I put the E first, followed by the W, I get the word you. And if we do east here and west there, you, we got it wrong. Okay? So it must be west first, then east, and we're spelling the word we. Okay, now let's just get rid of this ugly thing here. We don't want that there. So we got west, we got east, we got north, we got south. But you know what, folk? You never ever just go up, down, left, right. Okay? Sometimes you go in between the north and the east, or the north and the west, or the south and the west and the south and the east. Okay, so we've got to give those directions some names as well. So let's look here. Between my north and my east, I've got northeast. Why not east-north? Well, north is more important to us, so we're going to put it first. Okay? Remember, we started off by looking at north and south, and we said that's our most important line. So we're going to call this point here northeast. This point over, this direction over here, northwest. Over here now, this direction between my south and my west, I'm going to call that southwest. Again, south coming first. And this direction over here, we're going to call that southeast. So we have our directions. We know where north is, where south is, where west is, where east is. We know where northeast, northwest, southwest, southeast is. And now we're able to take that information and we're going to apply it when we look at certain graphs. And later on, I've got some lovely questions where we're going to apply all this knowledge. Okay? It's like making a chicken pie, actually. We've got two different parts of the pie. We've got the crust, and then we've got the chicken and the mushrooms and all that lovely sauce. And we cook the chicken and the mushrooms and the sauce in one pot, and we take that crust and we make that separately. Once the crust is ready, and only once the chicken and the mushroom and the sauce is ready, do we then put the two together. But we can't put them together until they are both individually prepared. And that's exactly the same with Mapwork at the moment. We've had a look at maps. Okay, and we're going to look at it in a lot more detail. And we've now just looked at our different directions. We've completed the directions. We understand where north is, where south is. We're going to concentrate a little more on maps. Once we understand maps, we're then going to put the two together and come up with a delicious chicken pie, kind of. All right, so we've done that. We've looked at direction. Let's have a look now at maps in a little more detail. Now, what I'm going to do is I've brought an atlas into the studio today. And it's an atlas that I got from my school, and I'm sure whatever school you're in, your geography department have a whole lot of atlases. And let me just stop here for a minute and say this to you. Mathematical literacy is all about real life. And if you think maths literacy is a subject all by itself, boy, you've got it all wrong. It's part of life. And geography is also part of life. And I see no reason why you can't go off to your geography teacher and say to him, sir or ma'am, I'm doing map work in Mathslit. Is it okay if I borrow an atlas? So I went across to one of our geography teachers and I said, please, can I borrow an atlas? And she said no, so I went to another one and she said yes. And so I've got this wonderful atlas in front of me. Okay? And it contains a whole lot of maps. And we're going to look at some of them right now. So here I have an atlas. And in my atlas is a map. And it's a map of Africa. It's a map as well of basically the world. Okay? If the camera stands still and I shift this, you can see we've got North America, we've got South America, and there over there now we've got Africa. Now right at the bottom of Africa, this little funny colored brownish blob over there, that's South Africa. And in the middle of South Africa, in fact, just to the side of the middle is Johannesburg, and that's where I am right now, in Johannesburg. So this whole world thing here, there's a little blob over there, and that blob's me, okay? Coming to you from the studio. Let's have a look at the map, and let's try and understand a few things. The first thing we're going to notice from this map is that there are a whole lot of different colors. And these colors are actually showing different countries. So South Africa, as we said, is in a funny little kind of brownish color. Okay, we've got Egypt in a lovely peachy color. If I were to go across, I'd get Libya, and that's in another funny color, light brownish color, I suppose. Sudan's in a purple color below it. So this map is a map showing us different countries. Now, here's an important thing. Folk, we get so many different types of maps. Some map shows us the world, as the map we've just looked at. If we narrow it down, we can actually get maps that show us just continents. If we narrow that down, we could get maps that just show us countries. We can narrow that down even further to maps that just show us a province. We can narrow that even further to a map that shows us a town. We can even find maps that show us the layout in a complex, a housing complex. Okay? Here's even a greater thing. You could even find a map of your bedroom if you wanted to draw one. And that's a great exercise, and I'm sure by now your teachers actually asked you to do that. Because that's how I introduced my section of Mapwork. We get our boys in our class to sit down, and we say, right, draw a map of your bedroom. And they draw a little scale map of their bedroom, showing where the bed is, showing perhaps where their little bedside table is, showing where the map fits into, the lamp rather, fits into their map. Okay? So there are a whole lot of things that they can show in their bedroom. What a strange map. A map showing such a small area. And then if we go back to this map over here, oh my goodness, this map is basically showing us the whole of Africa over here. Okay? And if I slide this map across, you can see that this map's actually showing us quite a bit of the world. Huge map. Okay? Showing so much information. Right. Now, with this map as well, I want us to take note of something. You will see, and the shot here shows it quite clearly, these lines that are coming down this page. Now, your geography teachers would have told you that these lines are called lines of longitude. And then the lines running across my map are what we would call lines of latitude. Now, there are other lines that we need to focus on. So in maths literacy, we are not really worried about these lines of longitude and lines of latitude. We are worried about other types of lines, lines that are called grid lines. Okay? Now, what grid lines are is this. So what I'm going to do here is I'm going to just quickly try and jump to an empty page, and I'm going to draw some weird little shape here, okay? What are we going to call this? We're going to call this, I don't know, it's my country, all right? So we're going to call it Mr. T's country, okay? I would have drawn South Africa, but if I draw South Africa, I may get sued for distorting our entire country here. So I've made up a country, it's called Mr. T's country, and that's what it is. Now, what I can do is I can have certain towns in my country. So let's say I were to have a town here, and I'm going to call that town A. Over here, I'm going to have a town, and I'm going to call that town B. And over here, I've got a town, and I'm going to call that town C. Okay. Now, this is a very basic and simple map. But were I to suddenly show you this map, oh my goodness gracious me. There is so much information here that if I were to look at this information and I were to say to you, find the city of Gotham Bay, you wouldn't even know where to start looking here. And so we make life much easier by drawing certain lines, okay? And we call these lines grid lines. So here's my country, and what I'm now going to do is I'm just going to use a different color, pink, why? Just cause. And I'm going to say, let's pretend there are a whole lot of lines, and we're going to call them grid lines, running down this page. Okay, there they are. Oops, run out of pink. Okay, here are my grid lines. And I'm also going to put some grid lines running across my page. There they are. There they are. Okay. Now, most maps have these grid lines. And these grid lines are put here so that it makes life easier for us to locate certain things, okay? Or locate certain cities, or locate certain places of interest. So we're going to look at these little blocks, and we're going to give each of these little blocks a name. I'm going to call this whole row, okay, or rather column, I'm going to call this column A. Column B, column C, column D, column E, column F, G, H, okay, and so on. So the columns running down are called by letters. The columns running across, I'm going to call them by numbers. So I'm going to say this is column row 1, row 2, row 3, row 4, and finally row 5. Now, I say to you, look at city A. Now, folk, again, my map's very simple, so you can say, oh, there it is. But if I had a whole lot of cities, like that previous map I showed you, where there was so much information, it would make life very difficult trying to find the different cities or towns. So what we would say is, you got to find city A. City A is in block C3. So it has its own little address. And the address for city A is C3. Let's see. A, B, C. So we know A, town A, is somewhere here. And we also know it's in row 3, somewhere along this row. So C and 3 meet over here. I know city A is somewhere over there, and voila, there it is. Straightforward. And this is a very, very basic illustration. You're going to see later on when we look at past test questions and past exam papers how complicated it can actually get. But if we understand the grid system, and if we get to understand the fact that every place has a little address, we'll find the places very quickly. So back to this quickly. Let's have a look at B, right? B, I'm going to tell you, is in block H1. Can you see it straight away? Of course you can. First of all, because it's an easy map, but also because I've just told you H is somewhere here, row 1 is somewhere here, it's got to be in that area, and there she is. C, can you give me C's address? If I had to say, if you were telling someone, find city C, it's in block number, what block would you tell them? You would tell them B1. But you can't get easier than that. It's so straightforward, it's so basic, and yet at the same time, it's so exciting. Right, now, what we need to do now, and let's just find where we are here. So we've had a look at direction, we've had a look at the grids, now we come to the part that so many students battle with. Man, students, let me tell you this. It's not as hard as it seems. And that's the section or the subsection on scale, right? So what do I mean by scale? Well, there are two types of scale we can use. The first one is something called a line or a linear scale. Now let's have a look at this. I'm going to just get it out to the top of the page here for you, right? So here is a scale, and what this scale is saying, this line scale, is the distance from this point through to that point is 100 kilometers. Now, folk, it's obvious that that is not in real life 100 kilometers. 100 kilometers is very, very, very far. In fact, if you know where Durban is and you know where Pietermaritzburg is, 100 kilometers is even further than that. So it goes further than Durban to Maritzburg. And yet this scale, if we look at it, is telling us that this distance is 100 kilometers. Well, the truth is it's not telling us it's 100 Ks. It's actually telling us it represents 100 kilometers. And that's a big difference. There's a difference between representing and the actual size. Here's the actual size. Here is a representation of that size. Okay? So let's have a look. So we are saying that this distance is 100 kilometers. Well, what is that distance? Now, I'm going to take a ruler here, and we're going to use this ruler. This was given to me by one of my students. I'm not sure if he knows how to use it, but I'm very pleased he has one. Okay. Unfortunately, though, it's quite clear, so I'm not going to use this one. I'm going to use a wooden one, and it's rather a long one. You probably won't have a ruler like this on you. You've probably got more like something like this. Okay, a normal little 30 centimeter ruler. However, for this presentation, I'm not going to use it because you won't see it on the screen. So we are going to use this wooden ruler so you can see it, and you'll see it when I show it on the screen. So let's have a look now back at the screen here. So we have 100 kilometers. But if I were to put my ruler down on the screen, I would actually see that from the beginning all the way through to the end of the 100 Ks is, I measure it to be 220, about 225 millimeters. Okay, so what I'm telling you is this, that 225, so let's change the color to something we can see. So 225 millimeters represents 100 kilometers. Okay, here is the biggest hint I can give you. Always, before you even start the question, before you even go further in the question, always write down what number represents the map or the distance on the map, and what number represents the distance in real life. So let's have a look. We got 225 millimeters and I got 100 kilometers. Now, we know that the 100 kilometers is not actually on the map. So this 100 kilometers is real life. This 225 millimeters is what is on the map. Okay? So 225 millimeters on the map represents 100 kilometers in real life. So what does 1 millimeter on the map represent? Let's have a look. How do I get 225 millimeters to 1? Well, to get from there to there, I divide by 225, don't I? If I say 225 divided by 225, I would get 1. So in the same way, I've got to do the same this side. I've got to say 100 divided by 225. So 1 millimeter on the map actually represents 100 divided by 225. Let's do that. 100 divided by 225 equals, and I get 4 over 9, I don't want that, I get 0.44, and I'm going to round that figure, so it's 0.44 what? 0.44 kilometers. So if I were to have a map with this bar scale, okay, or this line scale, what it actually means is every millimeter on that map represents 0.44 kilometers in real life. In other words, just under half a kilometer in real life. So let's say, and I'm going to do this on this map again, let's say I want to know this distance to that distance. So back in my make-believe country, Mr. T's country, I have town A and I have town B, and I want to know what is the distance between those two towns in real life. But I've only got them on the map. So what am I going to do? The first thing I'm going to do is I'm going to take my ruler and I'm actually going to measure that distance. So let's do that. So we put our ruler down, but now let's just stop for a minute, because here we have a problem. And our problem is this, that the marking for town A is a blob. And if you look here, my blob in this case is just over 10 millimeters or 1 centimeter. So how do I use this blob? Where do I start measuring from? Now, folk, if you get a map and they ask you to measure from one point to another, and they give you a dot on the map, take your reading from the center of that dot or that blob or whatever is on that map at the time. So looking at our map, I'm going to say, right, my distance between A and B, I'm going to take the middle of that dot, and I'm going to show you by putting a little pink dot there. Okay, that's not quite in the middle, we'll pretend it is. And another pink dot there. Sorry, every time I do that, my dot moves. Okay, but we'll find the center of those dots, and then what we're going to do is we're actually going to measure it. So from the center of the dot to the other center of the dot, and folk, I get round about 275 millimeters. 275 millimeters. Now, guys, the distance between the towns is not 275 millimeters, but it's represented by 275 millimeters. So the first thing we're going to write, do you remember what we did over here? We said, oopsie, let's go back here. We said that, and I've definitely lost where I am, sorry. Okay, here we go. We said we write on the map and real life. So what I'm going to write here now is I'm going to say on the map and real life. Now the first thing I know is 1 millimeter on my map represents 0.44 kilometers in real life. We measured 275 millimeters. So what's that in real life? Well, how did I get 1 to 275? I multiplied by 275. So what am I going to do this side? I'm going to say I've got 0.44 kilometers times by 275. And that's going to give me the distance in real life. Out comes the calculator. And we say, let's clear all this quickly. So we're going to say 0.44 multiplied by the 275 equals, and we get 121. 121 what? 121 kilometers. So if we look here again, we got town A, town B, and I say to my friend, I want you to go from town A to town B. How far is it, does he say? Well, I'm not going to say to him, it's 275 millimeters, because that's a joke. He's just going to take a little step forward and be at the destination. Rubbish. I'm going to say to him, well, actually, I calculated it, and it's 121 kilometers. Easy? Of course it is. But we're going to have to practice that a little bit, okay? And we're going to have to really work at that, because that is a concept that so many students find difficult to understand. Now, the exciting thing about this scale, this bar scale or line scale is this. I want to show you something. I think this is going to illustrate it nicely. Let's have a look at my picture here. And what I'm going to do is I'm just going to rub all this stuff out here quickly. And I'm going to draw a little map for you again. Okay, so there all that goes. Now, what I'm going to do is I'm going to put my little town A and my little town B over here. Okay, and let's even have a little town C over there. Now, what I'm going to do is I'm going to take this entire image and I'm going to reduce it. And I want us to see what's going to happen between town A and B, between the distance of town A and C, and especially what's happening to the distance of my bar scale, or what's going to happen, if anything, to that bar scale. Let's have a look. Back over here. Watch carefully. I'm going to push a button. Wham! And everything got smaller. Okay? But when I say everything, I mean everything. The distance between A and B shrunk. The distance between A and C shrunk. Between C and B shrunk. But most importantly, folk, the bar scale also shrunk. All those distances shrunk in proportion. In other words, the scale may have reduced itself in half, let's say. That would mean the distance between town A and town B also reduced by half. The distance between town A and town C also reduced by half. So although everything's smaller, my bar scale is still important, or my line scale is still important. It still counts. There's nothing wrong with using that bar scale if everything reduces, the whole map with the scale. Now, watch back here again. I'm going to enlarge everything. Watch how small my scale is. Watch how small the distances are. We're going to push one little button, and then like magic, everything got bigger. The distance between the towns got bigger, but important as well, the scale got bigger as well. Now, the next type of scale we're going to do is a number scale, or some people call it a representative fraction. Jeez, that's a big word. I can hardly even say it. So I'm going to call it a number scale. And what do I mean by a number scale? Well, do you remember when we worked out this distance and we said that 1 millimeter represents 0.44 kilometers? Okay? What we're actually saying is this, that 1 millimeter represents, now I'm going to change these kilometers to millimeters as well. How many millimeters in a kilometer? Do you remember? 1 million. Sheesh, that's a lot to remember. If you can't remember that, remember it in small chunks, okay? They're 10 millimeters in 1 centimeter. There are 100 centimeters in a meter and 1,000 meters in a kilometer. So it's 10, 100, 1,000, which make a million. 1 0, another 2 zeros, then 3 zeros. Okay, 6 zeros, a million. So if I want to change 0.44 kilometers to millimeters, I'm going to take that 0.44, clear our calculator again, I'm going to say 0.44 multiplied by 123 equals, and I get 444,000. So I know then that this represents 440,000 millimeters. In other words, folk, I have a number scale 1 is to 440,000. Okay? 1 millimeter on the map represents 440,000 in real life. So let's write that next to my picture over here. Okay? So we're going to say 1 is to 440,000. And again, let's just rub all this stuff out here. Now, folk, I'm going to do my little magic trick again. I'm going to reduce this whole picture. When we reduce it, we know that this scale is going to get smaller. We know the distance between A and B is going to reduce, the distance between A and C is going to reduce, and the distance between C and B is going to reduce. But what is going to happen to the numbers? Let's have a look. Okay, here's my image, reducing it, pushing our magic little button, voila, everything gets smaller. But to our horror, we notice that my number has not got smaller at all. It still says 1:440,000. Now clearly, folk, we can see, or we can conclude, that there's a problem with a number scale. And so what we have to understand is a number scale is fantastic if my graph, if my map is in its correct size. If I enlarge that map or I reduce that map, my number scale, in this case 1:440,000, is no longer applicable. It has to change as well, but it doesn't. So I always get very annoyed when some of my students take a map. Let's say they take this map over here, and you can't see it very clearly, but it's a huge map, and they say, sir, this big map, and it's a map of the Northwest Province, okay? And they take this map and say, yo, this is a big map. I'm going to reduce it, and I'm going to reduce this whole map onto one little A4 size. And there's nothing wrong with that. But where I get the horrors is when they try and calculate the distance from one spot to another, and they use the number scale, which has not changed when the map changed size. So the best scale to use, I always maintain this, the best scale to use is my Bioscale, because it's going to always remain in the same proportion as the map. We enlarge the map, the Bioscale gets bigger. We reduce the map, the Bioscale gets smaller. But the number scale doesn't. So back to our screen again, we see our whole map over here. I push my magic little button, and voila, everything gets big. The number remains the same, and for this map, that number is correct. For the reduced version, my number is not correct at all. Right. But I think we're ready now to take this one step further. Remember I spoke about the chicken pie, cooking the chicken, adding mushrooms, adding a bit of sauce. That's on one side. On the other side, I've got all that dough and I've made a lovely crust. So we spoke about direction, we've spoken about maps. Now let's bring it all together. And the way we're going to bring this all together is by looking at some questions. And that's exactly what we're going to do now. So what I'm going to do is I'm going to take us through a question or two. Okay, now, what we're going to do is this. We're going to read the question, and it says this: study this map of northern KwaZulu-Natal and parts of Swaziland and Mozambique. Okay, and then they're going to ask us some questions. And the first question they say, or rather ask, is in which grid block do you find Nongoma? Now, let's have a look at our map. Okay, there is our map. Now, remember earlier we spoke about giving blocks names. Let's have a look here. We're calling this column number 1. We're calling this column number 2, number 3, number 4. And then our rows, we're giving letters. We're calling that A, that B, and that C. Now, some maps will call the columns A, B, C, and the rows 1, 2, 3. This map's done it the other way. It's no crisis. It's not a huge train smash. That's fine. We'll still be able to locate our map. So we've got A, B, C, 1, 2, 3. And our first question is this: where is Nongoma? Well, the first thing we've got to do is find where Nongoma is. Okay? And here it is, right over here. Let me just get some color. Here she is, over there. Okay? Where is this located? Well, we know it's in row C, and we know know it's in this column. Where is this column over here? Let's go, here, and there it is, number 3. So where is this place? It's in row C3. So our answer is quite simple, 3C. Would I get penalized if I called it C3? I didn't think so, unless you got a real mean teacher. But you know what? If one of my students put 3C or C3, that student knows what he's talking about. He knows where to find that town. Okay? Now, this is the exciting thing about the grids, is this. That initially I said all we got to do is find non-GOMA. And we started at the top of the map and we worked our way down and we tried to find it, and eventually we found it. But if I say to you, hey, go to non-GOMA, it's in row, or it's in block C3, you would say, C3, there she is, right over there. Okay? That's why we use those grid lines. It makes our life so much easier. Okay, our next question then asks this. Okay? Before we get on to the next question, we've just discovered something here. We've discovered a scale. And this scale says 1 is to 2,500,000. It also gives us a bar scale, saying that the distance from this point over here all the way to that point over there represents 100 kilometers. Remember, it's not 100 kilometers, it only represents 100 kilometers. Okay, which one's the best one? We said the bar scale. Now, I actually cheated. Before this program actually started, I did this whole exercise at home. Okay, now I want to show you something, and I don't know if the camera is going to be able to pick this up, but we're going to try anyway. So here's the question. If you look, here's the map. Okay, here's my map that I'm working from. Can you see the difference? But if we look at my scale on my little sheet here says scale 1 is to 2,500,000. The scale here says this is also 1 is to 2,500,000. Clearly, this is not true because my little map is a lot smaller than this huge map I have in front of me. But what has changed is the bar scale. So over here, I got a tiny little bar scale. Over here on my diagram, the bar scale's much bigger. But we expect it to be because my map is a lot bigger. So guys, again, it stresses the fact that we'd rather use a bar scale than a number scale. All right, now, there are a few more questions we're going to ask about this. Let's say we were looking at Manzini and Ermelo. So what we've got to do is we've got to find Manzini and we've got to find Ermelo. And we've just discovered them. Here they are here, and I'm going to highlight them, okay? Manzini, oops, my goodness, that's not highlighting, that's just obliterating everything. Let's try that. No, that's not the one. Okay, let's just circle it, shall we? In fact, here we go. So we found Manzini. No, we haven't at all. Let's try again. Right, we found Manzini and we found Ermelo. And what we want to know is, what direction are we traveling if we travel from Manzini to Ermelo? So we're starting in Manzini, I want to go to Ermelo. Which direction am I going in? I'm traveling in a westerly direction. Remember, north, south, west, east. We're traveling westerly direction, or we're going west. If I were to go the other way, were I to go from Ermelo to Manzini, I'd be going east. Okay? Simple. You understand this. I know you do. Let's say you wanted to go from Vryheid to Piet Retief. So what we're going to do is we're going to try and find Vryheid and we're going to try and find Piet Retief, and I've just located them. So here is Piet Retief, and over here is Vryheid. And we're traveling from Vryheid to Piet Retief. So we're starting at Vryheid and we're going to Piet Retief. Let's just stop and digress for a minute. I like to do this because I like to talk. But if I were to say to you, we're going from Durban to Joburg, where's my starting point? Durban. From Durban. if I say to you, we're going to Joburg from Durban, where's my starting point? Durban. My starting point's always the place after the word from. So from Durban to Joburg, we're starting in Durban, because Durban's after the word from. To Joburg from Durban, again, we're starting at Durban, because Durban came after the word from. So here's the question now with Vryheid to Piet Retief. We're saying from Vryheid to Piet Retief. Where are we starting? We're starting at Vryheid. So if I'm traveling from this little village over here all the way to Piet Retief, in fact, the people of Vryheid are probably very annoyed now because Vryheid's not a village, so we'll call it a little town. So if I'm traveling from the town of Vryheid to the town of Piet Retief, I'm traveling in a northerly direction. We're going north, folk. If I were to say to you, we're going from Piet Retief to Vryheid, which direction am I going in? We're starting at Piet Retief, we're going to Vryheid. It's obvious, we're going south. Okay. Now, let's look at some more questions we could ask you with this map. Let's say we asked you to estimate the distance from Ermelo to Manzini. So here's Ermelo, there's Manzini. And I want you to estimate the distance from Ermelo to Manzini. Okay, let's do it in two ways, shall we? The first one, let's pretend we've got a little aircraft, a little aeroplane, and we're going to fly directly from Ermelo to Manzini. That's the first thing we're going to do. The second thing we're going to do is we're going to pretend we've got a car, and we're going to travel from Ermelo to Manzini. Okay? Now, folk, when we travel by car, we can't go straight. Well, I'm trying to explain that to my wife, and when you see our car, you'll understand that somehow she thinks, from here to there, let's just go straight. But generally, the normal man on the street's going to follow the road. And that road is not straight. It's going to have a little bend to the left and a little bend to the right. And so the distance is going to be a lot longer than what it would be if we got in an aeroplane. So we say we're going to travel by aeroplane. So let's do that. From Ermelo to Manzini. We're going to measure that distance. Okay. Now, first thing I'm going to say to you is this. We are going to use the bar scale. We're not using that number scale because that's ugly. It's already changed. Things have gone horrendously wrong. We can't trust that one. Okay? So, the bar scale. We know that on the map, and remember I always said write this, on map, real life. Now, real life, 100 kilometers. On the map, and let's measure it. From that point all the way to that point, I get 140 millimeters. Now, folk, if you've got this question in front of you, please remember this. Your question is on a piece of paper this size. It's a lot smaller map, and your scale's a lot smaller. So you're not going to get 140 millimeters represents 100 kilometers, okay? You're going to get something a lot smaller than that. In fact, if I remember correctly, you're probably going to get around about 29 millimeters represents 100 kilometers. But here I've got a much bigger one, so my scale's bigger. So I'm saying 140 millimeter represents 100 kilometers in real life. Okay, so 1 millimeter represents what? How did I get 140 to 1? I divided by 140. So I've got 140 divided by 140 gives me my 1 millimeter. So I'm going to do the same this side. 100 divided by 140. So I know 1 millimeter represents, and let's do this quickly. We've got 100. We get to divide it by 140, and we get an answer of 0.7142857, blah, blah, blah. Folk, we're going to round it off. Let's make it 0.71. Okay, so we've got 1 millimeter represents 0.71 kilometers. Okay, now, my question is this, give the approximate distance, and that's why I'm rounding off, okay? If I were to say I wanted an 100% accurate, then I would leave my answer as 100 over 140, Okay, I would say 1 millimeter represents 100 over 140 kilometers. In fact, let's pretend you've got a real strict teacher who's got to take off marks if you're not 100% accurate. So we're going to pretend that's the case. So let's leave it as 1 millimeter represents, 1 millimeter on the map represents 100 over 140 kilometers in real life. Okay, we've got that. Now, we want to measure the distance between Ermelo and Manzini. Remember our little aeroplane? Going to take off, fly in a straight line, and land. Okay, no turning, no twisting, no nothing, no turbulence up and down. It's a perfect day for flying. Take off, fly, land. Okay, so let's have a look at that. So the distance now I measure is between Ermelo and Manzini, 180 millimeters. And remember, we've got a big circle representing Ermelo, and that circle is about 8 millimeters in diameter already. So where do I measure from? I'm going to measure from the center of that circle. Okay? So from the center of that circle to the center of Manzini's circle, it's 180 millimeters or 18 centimeters. Let's keep it as millimeters because my map, my scale, I've used millimeters. So if 1 millimeter on the map represents 100 over 140 kilometers in real life, we know then that 180 millimeters, how did I get 1 to 180? I multiplied by 180, so let's do the same there. We're going to say I've got 100 over 140 times 180. Okay, so back to our calculator. And let's get it back to the 100 over 140. In fact, my calculator over here changed that to 5 over 7. So we could actually say, you know what, although it's 100 over 140, that's the same thing as 5 over 7. Calculators are wonderful things, okay? And here's another thing quickly, and I digress again, but you know I do that because you know I like to talk. But the wonderful thing about a calculator is, guys, it does all the work for you. Always use a calculator. Why stress your brain out when you've got a calculator? You paid a lot of money for it. Use it. So if my calculator says 5 over 7, let me write down 5 over 7. So let's have a look. Back to our calculator. We got 5 over 7. We're going to multiply that by 180, and we're going to land up with 900 over 7 kilometers. Now, if your mom or your dad asked you, how far is it from here to here? And you said to them, well, actually, it's 900 over 7 kilometers. They won't know what on earth you're talking about. So now that I've got my final answer, I have to have it in a decimal form. So 900 over 7, what is that? We push S to D, and we get 128,57. I'm rounding to 2 decimal places. Why? Because normally in your exams, the examiner will say to you, round to 2 decimal places where necessary. This is necessary, that's why we're doing it. So 128,57. So we're going to say 128,57 kilometers. Okay? So that is my answer now. Now, flying directly from here to here, we said we've calculated it to be 128,57 kilometers. Now, folks, the wonderful thing about this bar scale is this, that although you have a reduced map in front of you, if you've got this in front of you, okay, it's a reduced map, but the bar scale is also reduced. So whether we do this problem on the screen in front of me, which has a large map, or whether we do it on this map on this tiny piece of paper, or the tiny graph on the piece of paper, because my bar graph changed size, okay, in relation to the map, I should still get an answer of 128,57. Now, folks, that's exciting. That is just unbelievable that we can work on such a large map as we did, get an answer of 128,57, come to a smaller map, but also get an answer of 128,57. But that's because we used the bar scale. If we use the number scale, and remember here on my big map, my number scale says 1 is to 2,500,000. And on my small little map, it says it's also 1 is to 2,500,000. Clearly, we can't use that number scale when we're working with different size maps. Now, so we've answered the question. We said if we take off in an aeroplane and we fly between the two towns of Ermelo and Manzini, I'm going to have a distance of 128.57 kilometers. Okay, there it is over there. What happens now if I'm going to go from Ermelo to Manzini by car? Firstly, I have to stick to the road. That's very important. Your insurance company wants to make sure you do that. Your mother and father want to make sure you do that. Otherwise, they've got these humongous big bills of repairing vehicles. So we've got to stick to the road. When I look at my road, though, if we look at this diagram, we will actually see that my road has got all kinds of twists and turns. So what we've got to do is we've got to measure the distance of each section of that road. Now, if your teacher gives you a question like this, they will say, give the approximate distance. In other words, your teachers are going to understand that to measure the exact distance on the road, you can't be 100% accurate. But you've got to be pretty close. So what we're going to do is we're going to break this road up into different sections. And I'm going to say that my road, I'm going to measure this distance because I've got to go, oops, see, we've got a wrong color here. Let's try that again. Okay, I've got that little distance on my map. I've got to go on that road. Then I've got this little bit here. I've got this little bit here. I've got that little straight line. I've got a straight line there, a straight line there. So what I'm going to do is I'm going to draw straight lines where it's possible, and then I'm going to measure each of those straight lines. So I'm going to take my ruler and say, right, the distance from there to there is approximately 10 millimeters. From there to there is approximately 9 millimeters. And I'm going to add up all those little distances and get a huge final answer. Now, just now, while we weren't on air, I quickly measured all those distances. Okay, so I sat here quickly with a ruler, so we wouldn't take too long, and I got an answer of 250 millimeters. Now, it might have been 249, it might have been 252. I could have made a slight error. But the question would say, give the approximate distance. So let's write this down. So we've said here, we know we've got, and remember we always start every question on map, real life. So I'm going to say again, on the map and real life. Okay? And we said as well that on my map, remember we had a scale, 1 is to, and if you remember carefully, we said 5/7 kilometers. So 1 millimeter on my map represents 5/7 kilometers. We now have measured all those little segments on my route, okay? From this point to that turn, from that turn to that turn, from that turn to that turn, and we got a distance of 250 millimeters. Well, I did anyway. So I know that 250 millimeters is got to be so many kilometers. How did I get the 1 to 250? I multiplied by 250. What am I going to do to that 5/7? I'm going to multiply it by 250. So we got 5/7 multiplied by 250. Again, I'm going to take out this calculator and I'm going to say, right, we have, let's clear the calculator, we have 5/7. And I'm going to multiply that by 250. And what do I get? I get 1250 over 7. Now remember we said this just now. If your mother or your father, or in fact even if a friend said to you, how far is it from Ermelo all the way through to Manzini? And you said it's 1,250 divided by 7 kilometers. They're not going to understand what you mean. So now we have to change it to a decimal. So looking at our calculator again, we've got 1250 over 7. We're going to change it now to a decimal, and we get 178,57. Okay, so it's 178,57 kilometers. Now, do you remember that if I flew that distance directly from one point to the other, I got 128,57 kilometers. If I go by road and I got all the twists and the turns, I knew I was going to travel further. And in this case, I did. I traveled 178,57 kilometers. Here's a great question, and I'm just thinking about this right now as I'm talking. I think I'm going to give this to my grade 11s at the end of the year. I could actually say, what is the difference in kilometers between Ermelo and Manzini if I go by road instead of flying directly by aeroplane? And that's the only question I give them. Then they're going to have to calculate the direct distance. They're going to have to calculate the distance by road and then get one answer and the other answer and subtract the two. Geez, that's a good question. If my students are listening, I would pay careful attention to that one. And if other teachers are watching, that's a good question for a paper too. Right, so 128 direct, 178 by road. We expected the road to be longer because of all the twists and turns. In fact, if any of you have been in an aeroplane and you've flown from Joburg all the way through to Durban, you know the flying time is round about an hour, close to an hour. Depends on the mood of the pilot. Okay? If he's got a nagging wife at home, it could take you an hour and 20 minutes to fly it. But if he's got a wonderful wife with a great supper waiting for him, he could actually do it in 45 minutes. Okay? But we know round about an hour. If I got in a car, and if I was a good driver and stuck to the speed limit, and I drove from Joburg all the way to Durban, I could be looking at about 5.5, 6 hours. Okay? There are two reasons for that. Reason number one, I'm going at a much slower speed, obviously. But even if I were able to go at the same speed as an aeroplane, if that were possible, it would still take me longer because I got all the twists and the turns on the road. Okay. Right, let's have a look at another question. Another question which came up with this map was this. What is the actual area represented by one grid block? Sure. In other words, if I were to look here, and let's just obliterate Freiheit quickly, but if I were to look here and say to you, right, I want to know this block over here, how much area does it represent? You know, the formula for area for a square, or a rectangle rather, is length times breadth. So let's go all the way down here, and I'm going to say, okay, great. Area, we know, is length times the breadth. What I have to do is I have to find the length of the block and the breadth of the block. So back to our diagram. Here's our block. Okay? We're going to measure the distance of this block. Take my ruler. My ruler tells me that the length of one block, or the breadth of one block, is round about 90 millimeters. Okay? So we're going to say, great, it's 90 millimeters. Multiplied by the breadth. So, or the length, whichever way we want to call this. And when I measure that, I get round about 100 millimeters. So again, we're going to write here, it's 100 millimeters. But here's my problem. I am measuring the length and the breadth of the block on the map? That's not the question. The question is, what area is represented by the block in real life? So this 90 millimeters, we've got to change it to kilometers. How are we going to do that? Well, we know, and I'm going to do it in a different color here, we know that 1 millimeter represented 5/7 kilometers. What does 90 millimeters represent? Well, we're going to take 5/7 and multiply it by 90. So let's do that on our calculator, okay? In fact, I'm going to cheat a little bit here. 5/7 multiplied by 90 equals, and we get 450/7. Now, do we leave it as 450/7, or do we change it to a decimal? The decimal is 64,28571429. Now, again, it depends how strict your teacher is. But here's my golden rule. My golden rule is try and be as accurate as you possibly can. Okay? So I'm only going to round my final answer. So I'm going to leave that as 450/7. So right here now, we're going to write 450/7 kilometers. Multiplied by, what does 100 represent? Well, let's get rid of this. And let's say, back to our pink color, 100 millimeters must be 5/7 multiplied by 100. Back to our calculator. We're going to say, let's multiply 5/7 times 100 equals, and we get 500/7. Let's write it down. 500/7 kilometers. Now we're going to multiply those two together. So we've got 450. Let's clear our calculator. We have 450/7. I'm going to multiply that there now by 500/7. And I'm now going to get equals an answer of 225,000/49. Now, folk, if someone says to me, what area does that block represent? I cannot tell them, oh, it represents 225,000/49 kilometers squared. No, siree. We have got to actually give it in decimal form. So let's do that. Push our S to D button, and there it is. 4,591, 4,591,84. Okay, so, 84. 84 kilometers? No, 84 kilometers squared, because we're dealing in area. Now, if you remember from our previous sessions, when we were talking all about perimeters and areas and volumes, you will know perimeter would be kilometers, area, kilometers squared, and volume would be kilometers cubed. We're dealing with area, kilometers squared. Okay, so one block represents 4,591,84 kilometers squared. Okay, now folk, what I'm going to do is we're going to go on to another question with a different type of map. So we're just going to fly along here quickly, and let's have a look at this question. So I've now got a map of Umgeni Valley Nature Reserve. So here is a map of a nature reserve, and we're going to answer a few questions from that. The first question we're going to ask or going to answer is one on direction. So a question states this: in which general direction would you be traveling if you went from Shelter Falls Camp to the main office? Now, we've got to find these places. So the first thing we're going to do is say, right, my main office is this building over there, okay? And my Shelter Falls Camp, let's look for it. We're looking, here it is, right over there. So we want to know what direction am I traveling if I go from the main office to the shelter fall camp. Now, remember, my north, my south, my west, and my east. Okay? I'm going in that direction. What direction is that? Going to be southeasterly direction. Okay. Now, a lot of these questions that we've got here today repeat or a repetition from other questions. So I'm going to select a few questions because we're running out of time and I really want to get a broad spectrum of types of questions that we could get here. Here's an interesting question. Let me just rub all this pink stuff out of here quickly, okay? We don't want to offend any of the boys. All right, so the question, here's a good question. The shaded area on the map represents wild vegetation. Approximately how many blocks are represented by this vegetation? So let's have a look here. You can see we've got this whole white patch with roads going through, and then we've got these shaded blocks. And we want to know how many shaded blocks do I have on my map. Now, if I have a complete shaded block, that's easy to count. Because I can say, hey, there's one shaded block, there's another shaded block, there's a third shaded block. But what happens if only half the block is shaded? Well, then I don't have a whole block, I have half a block. What happens if a portion of the block is shaded? Well, now we've got to estimate how much of a block that portion represents. So let's have a look here. And once I've counted blocks, we're going to mark them with a little cross, and let's go with the color green. Okay? So, and the question as well, by the way, would state approximately how many blocks. So we don't want to be perfectly accurate. And in fact, in this kind of question, one can't be. But we want to have a good idea. So let's have a look. So here's a block over here. Now, can you see there's a little section of that block that's taken up by road? You know what? I'm going to say we have one whole block. In fact, let's number it. There's a block. Here's another block. Part of it is taken up by this road. But you know what? It's such a small bit that I'm going to say I've got another whole block. Let's keep going down. Okay. Here's another whole block. Now we got to think very carefully. Because now, this block here, there's quite a lot that is not actually represented by the gray area. So, can we say it's a full 4 blocks? Well, let's have a look here. I've got a little gray spot here. If I took that little gray spot and turned it and fitted in there, this bit and that bit, we could actually say, hey, you know what? This little bit and that big bit make a whole block. So let's call that whole thing together block 4. Okay? Over here again, we've got a bit of a block here. We've got a tiny bit there and a tiny bit there. I'm going to say 1, 2, those 3 little pieces are going to make my 5th block. Here I've got a full color gray, that's easy, 6. A full color gray, that's 7 blocks. 8 blocks, 9 blocks. This is going well. Now we have a problem. Nearly half the block here is gray. But over here, nearly half the blocks are gray. So I'm going to say those 2 halves are going to make one whole block. I've got 10 blocks, right? Let's keep going. Here I've got a little bit. Now I can't use this because I've used this as my block 5. But I've got a little bit here. Let's come back to that one, okay? In fact, no, let's do it straight away. I'm going to say this gray and this gray over here makes a whole block. So we were on 10. And I'm now going to say that makes 11 along with those blocks. So those 2 blocks make a whole block. Can you see how we just not being 100% accurate? Okay? We're just kind of estimating. And guys, in this kind of question, that's what you got to do. And the question would say estimate. But I can't be unrealistic. If I've got half a block, okay, and I've got a tiny little section, I can't say a half and a tiny section makes a whole, because then I don't quite understand this whole concept of estimating, right? So let's look at it, let's keep going rather. All right, so over here now, we have got 11. I'm going to say that makes 12. This makes 13. It's a little bit missing here, but I'll tell you where we'll make it up. This makes 14. I'm going to say this makes 15. Oi, what about that white? Okay, there's a piece of gray missing. Well, there was a piece of gray missing here, and we counted it as a whole block. So we're going to pretend that that little bit falls in there. We've got 16. Okay, this block here is going to form part of that 15 as well as that. So we're going to pretend that's still part of that. And then we've got this bit over here with a little bit over there. So we'll make that 17. And guys, this is about half a block. So you know what? I get 17 and a half blocks. That's what it represents. Okay. You may do it, and you may get closer to 17. You might even get closer to 18, right? Depends how you've estimated. As an examiner, if I did this and I got 17 and a half, and some of my students got 17 and some got 18, you know what? I'd give them the marks, because these guys understand the whole concept of estimating the little pieces and making a whole. So what if they're half a block out? You know what? There's understanding. If they suddenly got, wait, we got 22 blocks, something's wrong. No marks there, pal. But 17, 18, I'm going to give you the marks. Okay, so there I got 17 and a half blocks. The next question was this. What area does this shaded area represent in real life? Oi. So what are we going to do? Well, we've got 17 and a half blocks. I need to find out the area of one block. Now, it's very similar to what we did last time. In fact, it's identical. The first thing we're going to have to do is say, well, here I have my bar scale. I know the distance from here to here is 500 meters. Now, I want to stop. Do you remember right in the beginning of this program, I said to you, you get different types of maps. You get maps that show the whole world, and then you get maps that show continents, and maps that show countries, and then we go down to provinces in South Africa, and then we can go down to towns, and then we can go down to little street maps, and then we can even go into little complexes. Where's house number 3 in this complex, or house number 5 in this complex? Okay? When we started, the first few questions were so many millimeters represent so many kilometers. In this scale, we are told that the scale is in meters. Can you see that? So the distance from this point to that point does not represent so many kilometers, but rather it represents meters. So I'm going to take my ruler and I'm going to say, let's measure this distance. And I get around about 90 millimeters. So I know that 90 millimeters, okay, what do we always do? We say map and real life. Okay, on the map, 90 millimeters represents, what does it represent? It represents 500 meters. So 90 millimeters represents 500 meters. What does 1 millimeter represent? Well, 1 millimeter is going to be 500 over 90. What's that going to be on my calculator? Let's have a look. We're going to say I have 500 over 90 equals 50 over 9. So we know that is actually 50 over 9 meters. Okay? So 1 millimeter on my map represents 50 over 9 meters in real life. Remember, if someone asked you the question, what does 1 millimeter represent? You can't tell them it's 50/9. You've got to break it to a decimal. So you would then tell them on our calculator, we'd then say, hey, you know what? It actually represents 5,56 meters. But for the sake of this question, we know we haven't ended there. We've got to take the question further. So I'm not going to do any rounding until right at the end. Okay? So let's go. Now, the question, let's find out how big one block is. So let's do that. One block, we've got 70 millimeters. So I know area, oops, here we go again. Area is equal to length times breadth. The one is 70 millimeters by, and let's find, and over here we have 55 millimeters. Okay, so I've got 70 millimeters times 55 millimeters. Do you remember from our last example? We can't say 70 millimeters and 55 millimeters. We got to change it to what it represents in real life. So let's have a look at this. I know 1 millimeter was equal to 50/9 meters. So 70 millimeters is going to be 50/9 times 70. So on my calculator, we've got 50/9, right? So let's just clear this and start from scratch. We got 50/9, and I'm going to multiply it by 70 equals, and we get 3,500/9. I'm going to leave it as 3,500/9 because that's not my final answer yet. Okay? Once we got the final answer, then and only then will we round it. So 3,500, oops, 3,500/9, was it? Yes, it was. Okay, meters multiplied by, let's do this again. Instead of 70 now, we are going to say, what does 55 millimeters represent? So we're going to get our calculator, and we are going to say, and I'm cheating here, 50/9 times 55 equals, and we get 2,750. So 2,750/9 meters. Let's just double check. 2,750/9. So back to our calculation. Now that we have this, now we can multiply the two together. So I'm going to take my calculator and say, right, I've got 2,750/9. I'm going to multiply that then by 3,500/9, and I'm going to get an answer of 118,827. So let's write this down. 118,827,16. Okay, so 118,827,16 what? Meters squared, because we're dealing in area. Okay, great. So we found out the area of one block. But our question is, what is the area of all the graded shaded areas? Remember, let's look at our map. All these shaded areas, what does that represent? Well, I counted anyway, you might count differently, but I calculated we had 17.5. So what I'm going to say is this. Right, so we have 118,827,16 meters squared. We're going to multiply it by 17.5 because there were 17.5 blocks. So from my calculator, let's just clear this straight away. I'm going to say I've got 118,827.16. Multiply that by 17.5 or 17.5 equals, and that's my area. A huge number of 2,700,000 79,475. Now I've got to try and remember this because every time I touch the screen it disappears. Let's work in smaller numbers because that's what I like to do. My brain's small, I work small numbers. So 207, back to our calculator, 9475, comma 3 meters squared. Okay, that's it for the day. Thank you for your time. Thanks for tuning in. And you know what? I hope you're going to leave this session, take a small break, go find an atlas, and do some map work.